Hi, so this is my Logic Lock project. So it's designed as a project to teach my mechatronics students and control panel students some relay logic, making it a bit more fun. So I'll just go through what's involved. So we've got the relay board here, and then we've got the input. So you've got a push to make switch on the black and a push to break switch on the red. And what you have to do is make a combination of lights that will then open this solenoid that locks the box, so it will pull the catch in. So these are all latching relays, and the idea is that the junior engineer or student or apprentice has to wire it through. So you wire the latching and then you wire the output to each relay. So this is the output to the relays, and these are the latch connections. So it's all about learning about latching relays. So you've got 6 relays, obviously switch, push to make and push to break buttons. And then on the relay, you then on the second pole, you can then link all the poles in series. So this one here is linked to normally open, then normally closed, and various different, and then you create a combination in a chain, and that makes a circuit that then you can then unlock the solenoid. The catch is it then goes through a relay here, and that's activated by a timer circuit on this Raspberry Pi Pico, and the timer circuit is either activated when this clear cover is removed, or sneakily by me with an app or a website I've created that links to the Raspberry Pi, so I can start the timer and I can control the timer. So if the students manage to hack the system and defeat this little micro switch that starts it all off, I can then let them go for a little while and then start the timer myself. So it also teaches binary numbers. So obviously we've got 64 different combinations because we've got a 6-bit binary number there that we can make up. So I'll just demonstrate how it works. So what we do, we've got the wing nuts here, we have to take off one at a time. And then we lift the lid off, and that will make the micro switch, and then the timer starts. So the timer is, as you can see on my phone, it's in real time, so I can see how the students are getting on at decoding it. I can always, and also I can control, I can pause it and reset it and do several things with the mobile phone website. So that's sort of a closed network. So this is the actual Raspberry Pi Pico is a Wi-Fi access point, so it's not interfering with anything else on the network. So what you do is you then pick a combination. So we go high, high, low, and then you press load, and hopefully it would open, but it doesn't because we've got the wrong combination. So you can iterate through so we can clear that. You can hear the relays clicking, so if I hold the phone a bit closer, so to relay 1, you can hear it click on and off. So normally I'd use at least a 3-pole relay for doing this sort of thing, but because I'm trying to keep it down to space constraints, we're using a little inverter with a transistor. So when we're in the off position, that just inverts the signal to fire up the red LED, and then when we turn it on, when the relay's energized, the green LED comes on. So we can try another combination. So we can go 1 1 0 0 1 1. So we could try another one then. We could reset all these. Maybe 1 0 1 0 1 0, and then load, and nothing happens. So if we'd attempt to put the lid back on, it makes no difference. So once it's latched in and running, there's nothing you can do about it. I'll just put the clock back on. So we've got 40 odd seconds to run. So I'll just talk you through this one. So obviously this is the Pico timer. So we've got this nice little 4-digit 7-segment display connected through to the Pico. Got an alarm, and we've got a relay. So as soon as you've timed out, the relay will latch and you can't actually open it any longer. So I'm going to try a different combination now. So if I clear everything, so I'm going to go 1, 0, 1, and then if we press that, it will latch. It will work, but that's the actual combination, but we've not done it in time. So if I press load, it won't work. So we'll try again, and we'll do it with the right combination in the right amount of time, and we'll see what's hidden in the box. Right, so now it's time to try and unlock this logic lock. So we've learned something about binary numbers and relay logic and latching relays. So we use our skills to unlock this device. So just a quick recap. So push to break, push to make engages the relay, push to break disengages the relay. So green light represents a 1, red light represents a 0. These are all daisy chained through the relay changeover contacts. They then go through this relay by the timer that opens when the timer counts down, so we can't then activate it. And then the load then activates the solenoid, which then opens the lock. That opening also activates this relay that then sends a signal to the Pico to reset the timer. So we can then try some different combinations. So let's try 1, 0, 1, 0, 1, 0. So if anyone knows their binary to denary conversion, so some people say decimal, but it's actually denary, so we can then press load, and that should open our latch. Oh gosh, what's in here? So looks like somebody's hidden something in this box. So, oh my lord, what is this? I think this is another bomb we've got to defuse. So we've got radioactivity, hazardous waste, a red wire and a blue wire. It looks like we've got this logic bomber to defuse. So if you check out my next project, we'll learn how to defuse this bomb.